Hi, I am Arib. You are watching my YouTube channel. What is star delta starter, types, application and working? Starting a three-phase motor is never as simple as flipping a switch. Large motors draw heavy current at start, up, and that sudden surge can strain cables, reduce voltage stability, and shorten equipment life. This is exactly why engineers often ask, what is star delta starter and why it remains widely used in industrial setups. A star delta starter provides a controlled method of starting induction motors. Instead of applying full voltage instantly, it reduces stress during startup and then allows normal operation. Understanding why star delta starter is used helps explain its popularity in factories, pumping stations, and commercial facilities. Its balanced design makes it a reliable and practical solution for many motor-driven systems. What is star delta starter? Think of it as a reduced voltage motor starting method. It initially connects the motor windings in star configuration to lower starting current and then shifts to delta configuration for normal running. The function of star delta starter is to limit inrush current while still allowing the motor to reach rated speed smoothly. This method protects both the motor and the power supply network. Engineers choose this system because of its simplicity and reliability. In simple terms, it provides a balanced solution between direct online starting and more advanced electronic soft starting systems. How does a star delta starter work? To explain how does a star delta starter work, the process begins with reduced voltage in star mode and later shifts to full voltage in delta mode. This transition is automatic. The staged operation protects the motor and electrical system while ensuring smooth acceleration and controlled startup performance. Star starting stage. At start, the motor windings connect in a star configuration. This reduces voltage across each winding to approximately 58% of the supply voltage. Lower voltage means lower current draw. This stage explains the early phase of how does a star delta starter work. Reduced current minimizes electrical stress. Because star mode provides only about 33% of the motor's rated torque, the starting torque is very low, which is a limitation and not a protective feature, meaning some loads may not start. Under star connection. Current reduction mechanism. The key reason why star delta starter is used is current reduction. When voltage decreases in star mode, the starting current drops significantly. This protects transformers, cables, and switchgear from overload conditions. Reduced starting torque also lowers mechanical shock. By controlling current during the most demanding moment, the starter ensures smoother motor acceleration and longer equipment life in industrial and commercial electrical installations worldwide today. Timer-controlled transition. The transition occurs when the motor reaches sufficient speed and torque, usually 50 to 60% of rated torque, often corresponding to a preset time rather than an exact percent, because no speed feedback exists in standard star delta starters. The star contactor disengages and the delta contactor engages. This sequence explains how does a star delta starter work during switching. Proper timing prevents overlap between contactors. The transition must be clean to avoid electrical faults. Automatic switching ensures safe, consistent motor startup without operator intervention. Delta running stage. After switching to delta, the motor receives full line voltage. Now it delivers rated torque and operates normally under load. This final phase completes the function of the star-delta starter. The motor continues running in delta mode until it is stopped. Star-delta switching is not inherently smooth. Open transition designs introduce a brief supply interruption that can cause a current spike, torque dip, and occasional mechanical shock. A genuinely smooth changeover requires a closed transition star-delta starter, which is less common due to added cost and complexity. Types of star-delta starter. There are different types of star-delta starter designs available depending on control requirements and automation level. Each type serves the same purpose but differs in wiring and operation style. Understanding the right type of star-delta starter helps ensure safe installation and reliable motor performance in industrial systems. Manual star-delta starter. Manual starters require operator control during switching. The operator initiates star mode and manually changes to delta mode. This type of star-delta starter is simple and economical. However, it requires attention during operation. Manual control increases the possibility of timing errors. It is typically used in small-scale industrial environments where automation is not necessary and motor operation is supervised closely. Automatic star-delta starter. Automatic starters use timers and contactors to handle changeover. This type of star-delta starter is widely used in industries because it removes human error. The timer ensures proper delay before switching to delta. Automatic control improves reliability and safety. It is suitable for medium and large motors requiring consistent startup performance without constant supervision in industrial applications worldwide today. Semi-automatic starter. Semi-automatic versions combine manual control with timer-based switching. Operators initiate startup, but the timer controls the transition. This provides better safety than purely manual systems. It balances cost and automation. This option is suitable where moderate control is required. It offers improved performance compared to manual systems while maintaining affordability in small industrial environments. Application of star-delta starter. The application of star-delta starter is common in systems where high starting current must be reduced. Its balanced startup makes it ideal for industrial and commercial operations. Understanding the application of star-delta starter helps in selecting the right starting method for motors. Pumps and water systems. In pumping systems, gradual startup prevents pressure surges. This is a major application of star-delta starter. Smooth acceleration reduces mechanical stress on pipelines and couplings. It improves equipment lifespan. Pumping systems benefit from reduced starting current and improved reliability. This method ensures stable motor performance in water treatment and irrigation installations. Compressors. Compressors require controlled startup to prevent torque shocks. Reduced current limits mechanical strain. This is another key application of star-delta starter in industrial setups. Stable startup protects moving parts. Reduced voltage dips help maintain overall electrical system stability. Controlled acceleration improves operational reliability in compressed air systems and industrial refrigeration equipment. Conveyor systems. Conveyors benefit from smooth motor acceleration. Sudden jerks can damage belts and gears. Using this starter prevents abrupt movement. It improves mechanical lifespan. Conveyor applications highlight why star delta starter is used in material handling systems. Reduced mechanical shock improves operational safety and reliability in production facilities and logistics centers worldwide today. HVAC installations. Large fans and air handling units draw heavy starting current. This explains why star delta starter is used in commercial buildings. It stabilizes electrical load during startup. Reduced current prevents voltage dips. HVAC systems require smooth operation to ensure comfort and efficiency. Controlled startup protects both motor and supply network. How to connect star delta starter? Understanding how to connect star delta starter requires correct wiring of contactors, overload relay, and timer. Proper installation ensures safe operation. Learning how to connect star delta starter correctly prevents faults and ensures smooth transition between star and delta configurations in motor control systems. Main power connection. Connect supply lines to the main contactor. Ensure proper phase identification. Secure connections tightly to avoid loose wiring. Proper grounding is essential. This is the first step in learning how to connect star delta starter safely. Correct power connection ensures stable operation and prevents electrical hazards during startup and running conditions in industrial electrical systems worldwide today. Star and delta contactor wiring. Wire the star and delta contactors according to motor terminal configuration. Ensure interlocking between contactors to prevent simultaneous operation. Correct wiring prevents short circuits. This stage is crucial when understanding how to connect star delta starter safely. Interlocking improves safety and ensures smooth switching between star and delta modes. Timer and overload setup. Install and set the timer according to motor specifications. Adjust switching delay properly. Connect overload relay for protection.